Sizing of solar battery. In this session, we're going to be talk about how we can size the solar battery, how we can decide the number of battery requirement, how we can decide which battery should be connected in the series or the parallel combination. So for that purpose, we take an example first. Size the battery for the energy consumption of 2000 watt hour. So if the consumer is consuming the 2000 watt hour of the energy, then how we can size the battery for fulfill the load requirement of the consumer. So for that purpose, we are using this formula. Total capacity of a battery bank is equal to total power consumption in watt hour multiplied by number of days of autonomy divided by system voltage into percentage of depth of discharge. So basically in this formula, what amount of the watt hour consumption the consumer will have, that we have to consider first, multiplied by if the frequent electricity outage is happening in the remote places, so that the consumer requires actually 2 to 3 days of the particular battery bank autonomy over here actually. If the frequent electricity outage has not been there in the particular area, or every time if he's charging the solar battery with the help of the panels, then the 1 day of autonomy will be sufficient in the designing over here. So for that purpose, we're going to take the 1 day of a designing for this corresponding case study. Divided by system voltage we have to take. So basically the system voltage is nothing but what is the solar charge controller we are selecting in the system. So that is called as the system voltage. If we are giving the solar panel power to the charge controller within the range of the 24 volt, and the solar charge controller we are selecting who is charging the solar battery at a voltage of the 24 volt, so that time it is called as the system voltage over here actually. So this we are taking for this calculation as an 24 volt into the percentage of the depth of discharge. So basically whenever we size any kind of a battery actually, so that time how much amount of the power from the battery we have to utilize, it depends upon us actually. If we are utilizing the power from the battery up to the 50% and then we are cutting down the supply from the battery, so that up to the 50% when the battery will go into discharge, we are not consuming power from the battery. So that time we are say the depth of discharge will be the 50% over here. Whenever we are utilizing the power from the battery actually up to the 90%, only the 10% will remain in the battery and the rest of the 90% we are taking out from the battery for the corresponding consumption for the consumer over here. So that time we can take the depth of discharge as a 90% over here. So it depends upon the consumer actually, whether he wants to go for the 50% of a depth of discharge of a battery or 90% of the depth of discharge of a battery. For longer lifetime of a battery actually, we're going to prefer the 50% of the depth of discharge. But for the economical running of a battery actually, we can go for the 90% of the depth of discharge. There are two kinds of the batteries are there actually. One is your lead acid battery, other is your lithium ion battery. So every variations in the battery actually, the percentage of depth of discharge is varying over here. So whenever we see the data sheet of the battery actually, so that time in the data sheet it has been mentioned what is the percentage of depth of discharge the corresponding battery will have. So let's say for the calculation I am taking the 50% of the depth of discharge, which is stands for the 0.5 as a multiplication factor. So we take the 2000 watt hour multiplied by 1 day of autonomy divided by the 24, which is the system voltage of the battery bank voltage, we can also say, multiplied by 0.5. So after this calculation, we'll get the answer as total capacity of a battery bank required to fulfill the need of consumer. It is 166.67 ampere hour. So closer to that, whatever the market standard has been available, so that battery we can select it over here. So let's say we're going to select the battery of the 200 ampere hour, which is a 12 volt solar battery, can easily be available in the market. So once we have selected the individual, now we're going to see how many number of a battery that is required to be connected in the series combination. So for that purpose, we use the formula that the battery bank voltage divided by the voltage of each battery. So in this case, the solar charge controller is having the rated voltage of 24 volt. And that is why the battery bank voltage is also the 24 volt. This divided by the voltage of an individual battery what we have selected. So from this we can calculate how many numbers of a battery required to be connected in the series combination. Now we're going to see how many numbers of a battery required to be connected in the parallel combination. So for that purpose, we use this formula: total capacity of a battery bank divided by capacity of the individual battery selected. So in this case, as per our calculation, total capacity of a battery bank is 166.67 ampere hour divided by the capacity of the individual battery we have selected, which is a 200 ampere hour. So by this calculation, we get an answer close to the 1 over here. So the number of a battery that to be required to be connected in the parallel mode are 1. So total number of a batteries to be required is number of a batteries in parallel multiplied by number of a batteries in series combination. So parallel will have a 1 and the series will have a 2 kinds of the batteries over here. So by doing this calculation, total number of a battery required are 2 over here. So by this calculation, we can size actually how much number of ampere hour capacity will be required, how many number of a batteries to be connected in the series combination and required to be connected in the parallel combination. So from this, we can just estimate total number of a battery to be required to fulfill the need of the consumer at particular watt hour of the capacity.